Hello, good day, guys. Nice to meet you back. This is our first lesson in learning carbonate. This lesson is very special, prepared for Coordinated Science IGCSE 0654. So today's chapter is chapter 13, carbonate, and I will cover in this first lesson today. Okay, so let us see what we are going to learn today for our lesson. Okay. IGCSE Coordinated Science, Carbonate. Okay. So in this lesson, we are going to cover about describe the manufacturing of lime, calcium oxide from limestone, which is calcium carbonate in terms of chemical reaction involved. So this is our main discussion today. So for some of you, it's the first time you are hearing about lime. Do not worry. We are going to discuss about this. And for some of you, you might have heard about limestone. Now you know the limestone is calcium carbonate. Okay, so if you never seen limestone, don't worry, I have some sample for you. The first thing that I like to show to you today is this. So whenever you go to the beach or ocean, you like to collect some beautiful shells when you were small, and even today. So all these shells are example of limestone. Now, beside these shells, you also sometimes come across a beautiful things made from limestone. Okay, example, I have a very beautiful handmade crafted box made from limestone. Okay, you can put something precious. Now, other sample of limestone, when you see any statue, okay, all these are made from limestone. Now, if you still are worried, oh my God, I do not know limestone, look behind. The wall I usually contain limestone as well. Okay, so guys, so don't worry. So there's a few questions I like to pose to you before we begin. Okay, the first question is, what is the formula of quicklime? Okay, which is also known as calcium oxide. The next one, what is the usage of calcium oxide? And the third, what is the source of calcium oxide? So if you can think about the answers for this question, you are in the right path of today's lesson. Okay, so if you have a pencil, grab a pencil and pause the video and write down the answer for the first one. Okay, and if you can think about the answer for the next one, is good. And of course, it is better that if you know what is the source of calcium oxide. Okay, try to think what is the two objects that I showed to you just now. Okay, are you ready to see your answer today? Okay, very good. So calcium oxide, the chemical formula is Ca O. Okay. Now, the next question. What is the usage of calcium oxide? Okay. What is the usage of calcium oxide? So, try to think what could be used for calcium oxide. The word calm is quicklime. Okay. Sometimes you have heard about the lime. So, any idea? Are we ready to see the answer? Okay. Now, there is a many usage of calcium oxide. Okay. So, firstly, just like calcium carbonate, calcium oxide is also used in the construction industry. Okay, it's added into the mortar when they want to make the building. All right, for example, to make the wall, to make the floor, maybe to make the ceiling, everything, it contains calcium oxide. Second, it can be used as a drying agent, okay, to absorb moisture and largely used in agriculture. Okay, for an example, the soil is in a very high amount of water or too moisture. So the farmers usually applied calcium oxide on the agriculture land. Now, neutralizing agent, as you know, large farmland are exposed to acid rain, making them unsuitable for the growth of any vegetation or plant. Therefore, farmers do use calcium oxide to spray on the surface of this farmland. So it can neutralize the acid rain. Now, the third one, since you have been a science student, you had come across the usage of lime water. Okay, probably some of you trying to figure out where have you seen or used the lime water? You are right. Lime water is used in testing presence of carbon dioxide gas. So the lime water is itself produced from calcium oxide. Okay, so when calcium oxide is added with water, it changes into lime water. Okay, this is how it is made in the laboratory or even in industry. Now, so the first three is very important because it is usually discussed in our syllabus. Just to add up more interesting information about the usage of calcium oxide, I have included point number 4 is to remove odor in the graveyard. Okay, so as you know, decomposition of any organic compound, whether it is from animal body or even vegetable, does produce some odor. So even in the graveyard, they usually apply calcium oxide because it can absorb the odor or the smell. And the last point is information for you. Calcium oxide is also used to treat organic waste. Okay, for example, in the sewage treatment. Okay, for example, in biodiesel treatment. So they use this calcium oxide. But I like you to remember the first three very much because they can be asked in our exam. It is used in construction industry. It is used for drying or neutralizing agent. It can be used to produce lime water. Okay. Now, We go to our third question today. This is the important part of our lesson today. What is the source of calcium oxide? From where we can get calcium oxide? I know most of you are thinking, I can find calcium oxide in my school laboratory. It is correct. However, the question is, what is the source of calcium oxide? From where the calcium oxide is derived? Okay, give you 2 minutes, try to think over this. And if you are ready, we'll see the answer together. Okay, so when we heated a limestone, okay, so again, limestone usually can be derived from nature. For example, the shell contain limestone, or from mining of the stone, all right, the limestone from the mountain or from the cave, they can get the limestone. Okay, so when the limestone is heated, it can break down into calcium oxide and carbon dioxide. So this is an example of thermal decomposition. The common name for calcium oxide are quicklime or lime. Okay, so we have learned a few names. Limestone referring to calcium carbonate. Okay, limestone is calcium carbonate. Quicklime or lime are usually referring to calcium oxide. Okay, so you can see this equation. I would like the student to take note this equation as well. You can see how it works. You have one molecule of calcium carbonate. This molecule break off to form carbon dioxide. Okay, so if you are able to remove this this carbon dioxide into here, you will realize what is left is one Ca and one oxygen. So this is one of the way to remember. Remember limestone, you remember carbon dioxide, then you know what is left is calcium oxide. So this equation is always asked in the exam for the past years. So memorizing this equation at a certain extent is very helpful for you. So remember, calcium carbonate can produce calcium oxide and carbon dioxide. Okay, now, so let us go into the industrial process, how they make this calcium oxide. Since we know they will heat up this calcium carbonate. Okay, so when we heat up this limestone, it strongly breaks into calcium oxide and carbon dioxide. Thermal decomposition, commonly known as quicklime lime. So quicklime is usually made in a furnace. Okay, this is usually made in a furnace, and I'm going to show you a picture of furnace. Okay, this furnace is called a lime kiln. Okay, and this is a very specific lime kiln. It's a rotary lime kiln. Rotary means it is able to rotate. Okay, lump of limestone are fed in at the top. The limestone is strongly heated by current of a hot air. Okay, the rotation of the kiln helps the limestone mix with a lot of air, because when you start to rotate, you are actually mixing this limestone with the air. You are increasing the surface area of the limestone that is exposed to the air. Okay, the limestone decomposes to calcium oxide, quicklime. Then this is removed at the bottom of the kiln. So let us see the image of this kiln. Okay, so this is the kiln and it is rotating. So guys, this is, although in the image or in the picture that I show is look very small, in reality this machine can be as long as 50 meter. Okay, 50 meter, very long. Okay, 50 meter. And then in the diameter can be up to 4 to 5 meter depending on the size. If you have a larger diameter, it means it is able to produce larger amount of quicklime per day. Of course, the smaller machine would be producing a smaller amount of quicklime. Now, so by feeding the limestone on the top, okay, and the hot air is blown from this downward, and this machine is constantly rotating. So the limestone that is fed over here is started to mix with the air. And every time when this kiln rotate, you must understand the limestone will go and fall down. The limestone is going and fall down. Just like, for an example, you have seen a cement truck machine. It have a rotating kiln behind the machine, is constantly rotating in order to mix all the cement and mortar in a very good composition. Okay, so in the same manner, by rotating, we are actually mixing this limestone with the hot air. So as it moves downwardly, this limestone all are being transformed to quicklime and carbon dioxide. But as you know, carbon dioxide is a gas. It is evaporating up and moving from a pipe up here. So temperature increases as the limestone travels through the kiln. So from here down here, the temperature will keep on rising. And by the time you get the quicklime out, it is very hot. Okay, it is probably about between 900 Celsius to 1000 Celsius. Okay, it is very hot. Now, the last part for today's information about this lime kiln. This process is also sometimes referred in some books as calcination. So, according to the International Union Pure and Applied Chemistry, okay, IUPAC, it defined calcination as an heating to high temperature in air or oxygen. So that's why sometimes some books refer for you as a calcination. Okay, so the temperature is about 950 to 1000 Celsius or about 1200 Kelvin. This is known as a thermal decomposition because you require some heat. So calcium carbonate, for example, this calcium carbonate, it does not decompose to form quicklime. Same with this. If you leave it, they still remain as thousands of years as calcium carbonate. Only by a very strong heating, you can convert this calcium carbonate into calcium oxide. Okay, and finally, this is also known as endothermic reaction because the heat is absorbed for this process to break down this calcium carbonate. Okay, now, so a recap of our learning today. First, we need to know what is calcium carbonate. I hope you remember my beautiful shell as well my beautiful jewelry box made from calcium carbonate. Okay, the next part was calcium carbonate is usually processed or heated at a very high temperature to produce calcium oxide. All right. So the calcium carbonate that we know as a limestone, now we call it a quicklime or lime. So what is this usage of quicklime? Remember the first three things? Remember the wall or the ceiling or the floor? It is used in industry to make mortar. Number two, it is used as a drying agent or neutralizing acid in the soil for the farming. And third, make sure you remember this quicklime is used to produce lime water that we are keep using in our school laboratory to test presence of carbon dioxide. Okay, and how quicklime is produced? By a process called thermal decomposition using a rotary kiln. Okay guys, that is the recap for our learning today. For this lesson, I will continue the same topic in more detail about other usage of calcium carbonate and other part, and then we'll finish this lesson carbonate in my second lesson. Keep tuned with me. Hope to see you again. Have a good day. Thank you.